papers session at 12:30, and in the room next door we are going to listen to the speakers of those posters now, and they are going to briefly explain the most important parts of these projects, which are for the most part presented in this conference, and we wanted to share them with all of you. I will briefly introduce the speakers. We will start with the Assam project, improvement of self-reliance through mobility, and Christian Barret is going to make this presentation from the University Polytechnica of Catalonia.
Hola. Vale.
I'm going to talk about the Assam project, Assistance for Safe Mobility. It's a EU-funded project within the Assisted Living project, with 10 members from Spain, the Netherlands and Germany. Two companies, Ecobike and Linfante, participate in this project, and the Center for Independent Life in Catalonia, as well as the Polytechnica University. The goals of this project are very clear. Given the aging population and the fact that the aging population is translated into increased prevalence of diseases and illness related to cognitive impairment, thus reducing the quality of life of these users and their self-reliance. People, elderly people especially, that are locked up in their houses because they cannot do their day-to-day tasks in their neighborhoods. The Assam project aims at overcoming these problems and situation, providing assistance to mobility with a new platform or a new generation of platforms. For example, the Roland wheelchair developed in Germany, the iWalker developed in Spain, and the robotic tricycle with no name so far, but it is being developed between Ecobike and the UPC. These robotic platforms provide support to individuals to overcome their disabilities, but it also has different software to provide the cognitive improvement. One of them has a GPS mounted, adapted to the elderly, where they will be able to see a map with their favorite top spots, the pharmacy, the school of their grandchildren, or the nearby park. It can calculate the route from one place to another, and it could be done visually or with sound for the visually impaired people. The other assistance is aimed at avoiding obstacles with different sensors mounted on the platforms, with the aim of detecting the nearby obstacles in-house and outside the house. The platforms will actively help them in navigating in order to avoid obstacles, trees, urban furniture, or different barriers. And finally, the self-reliant Roland wheelchair, allowing the definition of our final destination, and the wheelchair will drive us autonomously. We can be fully self-reliant. The person is sitting, there is no physical risk, as opposed to the walker and the tricycle, where the person needs to make a specific movement. Therefore, the autonomous movement can only be used if the person is lying on the bed. They want the walker to go where they are. In this case, this could be fully independent or autonomous. The three platforms will be tested in 3 pilot places, the Netherlands, Germany and Spain, in 3 different phases. In every phase, we will try to receive the feedback of our users in order to incorporate changes into a latest version that best meets their needs. Here we have presented in this demo presentation the eye walker, providing support in the mobility, and it can detect the strengths and weaknesses of a certain individual. I highly encourage you to ask any questions you might have, or if you want to take a look at the walker, please do so. Thank you very much indeed.
Bueno, muchas gracias, Cristian.
Thank you very much, Christian. We are now going to take a look at the project, an innovative solution based in the interaction between man and machine in order to provide cognitive rehabilitation. José María Cogollo Delgado, a PhD and researcher in the Robotics and IT UPM CICIT Center. Thank you very much. Hello, good morning, ladies and gentlemen. Thank you very much for your attention. The paper we are currently presenting aims at providing a solution. We try to overcome a current problem with an innovative solution. This is quite new, and it's a real novelty in order to provide cognitive rehabilitation for patients with a certain disease called apraxia. The syndrome of the disorder of the action. ADS is the acronym commonly used. It is a rare disease here in Spain, but it's common in Germany and the UK, for example. And this is part of a European project with our website, coax.eu, and please take a look at it because it is most interesting. The leading coordinator of the project is Birmingham, which proposed the psychologists and engineers, along with 7 partners, including ourselves, the UPM, the Telecom and Industrial Engineering University, as well as other universities in Munich, other medicine consulting companies, neuro-rehabilitation companies, and it is a very ambitious project. The main goal being providing a system which can help patients in their cognitive rehabilitation. These disease, apraxia, the ADS, prevents them from doing day-to-day routines, preparing a cup of tea, or personal hygiene, for example, because it blocks their normal movements. They are completely blocked. They forget the purpose of the different projects, and we want to release them from the hospitals, and we want them to be able to rehabilitate themselves at home with a very simple system, a computer, a camera, sensors and systems. And if they are going to prepare a coffee or tea, or they are going to fix a tea, or brush their hair, it'll recognize what are they about to do, what are the tasks involved in the preparation of a tea, for example. They will see whether they are making mistakes, and they will duly inform them of the mistakes. We have done 1 year with the prototype, and the prototype, it's somebody fixing a tea. So what type of tea would you like to prepare? Tea with milk or without, with sugar or without? Once you've selected the type of coffee, they will boil the water on the kettle. They will put the tea bag or the sugar, and if there is any problem whatsoever, it'll communicate it to the user, the patient. There is a vibrating clock, and also depending on the mistake and the severity thereof, there might be an image or text. And if the patient does not respond to the first stimulation, they will receive a hint so that they really understand and they can correct the problem. To that aim, patients will have a watch with an internal engine for the vibration, but also a laptop screen that can act as an interface. We also have Kinet in order to detect the hand's movements and to obtain the positions with coordinates for the logarithms to be able to detect the failures, and the objects like the teapot, the teacup, the bottle of milk. They all have different sensors that can detect their space movement. Everything is combined for the algorithms to be able to recognize what are the tasks undergone, because this is an automatic system and it has to detect whether the task is done properly. As I have said before, we have recently launched a prototype, and the goal is to convey it to more difficult tasks, like, for example, washing themselves, brushing their hair, brushing their teeth, and over the coffee cocktail or the coffee break, sorry, they can ask any questions, or you can ask any questions you may have. Thank you very much indeed. We are going to take a look at the virtual lab for the healing of different environmental services. Nieto Hidalgo is going to present it from the University of Alicante. Hello, good morning, ladies and gentlemen. I'm going to introduce the virtual lab DAI of the University of Alicante. The group developed a platform for the integration of numerous robotic technologies and protocols in order to control them under the same interface. We can control any domotic device by using a web service. The platform was integrated into a real lab, a real domotic lab we have in-house that we normally use for the test. Developers can try their interfaces and the functioning of those interfaces. For example, if they couldn't do their test at the same time, two people, for example, switching on the light, switching off the light, you never know who did what. So that's the reason why we developed this domotic simulator, to allow every developer to have their own virtual simulator and to validate their own developments. This simulator counts on two modules, the editing module for the creation of the domotics installation with its corresponding devices, and from that module we move on to the second module, the simulator for the execution and simulation of the different digital services in the house. Not so long ago we also added another module in order to program the different devices with different workflows for the user or the homeowner to program the devices in a very simple and user-friendly fashion. As I said before, the platform comprising the numerous domotic these technologies was called simulator middleware for the interaction between the virtual and the real lab. The only difference being changing the web service address. However, the functioning is very simple. When you try the interface with the different controls, the simulator will then execute the different commands, and you'll be able to understand the functioning of this facility before actually mounting it onto the house. Therefore, you can try the different services without damaging the installation. As my colleagues just said, during the cocktail sessions, you can ask any questions you might have. Thank you very much.
Muy bien, gracias. A continuación vamos a...
I am going to give the floor to somebody who's going to present the rapid guidelines for web content using open source software. The poster will be presented by Teresa Diez and Maria Jose Dominguez, and Maria Jose will be precisely the person who will do this, and they come from the University of Alcalá de Henares. The work has been developed by the University of Alcalá professor and University Complutense professor. It provides the rapid guidelines for the assessment of a website by using the WCAG second version 2.0, so the latest version, and it also proposes some open source software for those who are not too techie savvy or who are not very familiar with this second version. If you want to ask any additional questions, you can ask them afterwards, but I'll explain the stages. 2 phases. First, you will use the toolbars proposed by Internet Explorer, as you can see on the slide, and the different icons. One of them has a bar proposed by Internet Explorer and the other one with Firefox. With these 2 bars, you can do a global assessment, such as on activating JavaScript, and to test the functionality of the website to make sure that all the information is accessible, even if we have the presentation here. It is also possible to test that the HTML tags and also the CSS presentation rules are correct, because if this is incorrect, this might lead to problems. We can also verify the website structure. That is it coherent? Does it have the proper tagging? Checking the images and the explanation thereof, and what could you read in case of eliminating the image? Is it fully understandable? We also propose the use of a reader, such as the NVDA, which is a free device, which will give us a general overview of the different problems on the website. And secondly, there are different tools that you can see to the left. These tools are fully automatic, and they can give us an assessment of this website from 0 to 100 in terms of accessibility criteria, and the different criteria proposed by the WCAG that have to be assessed one by one, but this will be automatically done by the tools. We can also see the numerous problems with one website that you'll have to see manually. I won't go into detail because, as I said, these are more technical issues, but please note that we've tried to check our experience in this type of assessment and teaching, and if someone is interested in running an assessment and they want to make sure that their website is accessible, they can do it without the need to be very savvy or very familiar with the WCAG guidelines, which are binding to the Spanish state. If you have any questions, as my colleagues said, you can ask them afterwards. Thank you very much indeed.
Muchas gracias, María José. A continuación, vamos a seguir con el proyecto Desarrollo e Implantación de un proceso de evaluación.
We are going to talk about the this assessment of reduced mobility drivers in the use of mobile cars. Juan Carlos Chicote, the R&D&I manager of Fundación Sensibilidad, is going to introduce this poster. Good morning, ladies and gentlemen. Please note that this is part of a ONCE Foundation funded project. These counted on different blocks. A, the transformation, installation and adaptation of a vehicle with numerous joysticks, mounting of joysticks. We've also designed and developed a driving simulator, and I'd like to explain the process linking the simulator and the car in order to empower drivers. First of all, as you can see on the left part of the slide, you will see the amount of users with reduced mobility when accessing the cars as passengers, but also as drivers when driving the car. This is paramount in order to understand the target of these type of actions. 400,000 plus people that can't really adapt themselves to the normal mounting and setting up of the cars, and this is very important, especially vis-a-vis aging population. This is a picture with these type of joysticks mounted into a vehicle. What we'd like to show at the left part of the slide is A, the users, and B, the technology. These are different things, and with this project we try to eliminate as much as possible the gaps between those two, and that is the reason why we designed a process that can be implemented into a driving simulator, including the initial phase, recording the background driving experience of the driver, the evolution of the physical features or impairments, and the simulator will in turn verify the best grip for the different joysticks. Is this a clamp or a bowl, in order to optimize the motor capacities of the drivers. And then we will run some tests of the mobility range of these devices in order to do a simulation with numerous scenarios, that is suburban environments, roundabouts, acceleration. You can measure timing when an unexpected event happens, and we have fine-tuned our process. If you are certain that the adaptation is flawless, you know the space situation, then, only then, we will move on to the standard stage. That is entering into a real car with their joysticks adapted to their needs, and then they'll have to renew their driving permit or driving license. The second slide, I think you can see it now. To the left, you can see the first tests with users, technicians, which are professionals very familiar with the movements of the wrist or the arm and the leg, and they are also very familiar with the cutting edge driving techniques. These technicians will assess the movement and capabilities of the drivers. As you can see in the top image, this is a user driving with a mini driving wheel and joysticks. Not only do they try it in urban and suburban environments, but also at day and night. And the other option is a full mounted joystick simulating acceleration and slowing down. The conclusions of this project are the following. We strongly believe that the introduction and implementation of this process allows us to overcome a gap facing these drivers when they have to renew their their driving license. This is a most useful tool, allowing them to know what was the best configuration for that user. And in turn, the users with adequate training and rehabilitation may have a full, complete brain map according to these driving configurations. If they are used to driving with a driving wheel, they'll have to change their mindset, but with training and endless hours in front of a joystick, they'll get used to it. And that is the reason why we believe these type of tools are very useful. Please, any constructive criticism, any feedback is more than welcomed, and I am sure it'll enrich our process. Thank you very much. Thank you very much, Juan Carlos. I am now going to give the floor to the preliminary design of augmented reality interfaces for the Azibot assistential robot. Felix Rodríguez Cañadilla is going to make the presentation, PhD student of electricity and robotics of Robotics Lab in the Carlos III University of Madrid. Hello, good morning, ladies and gentlemen. As my colleague just said, my name is Felix Rodríguez Cañadillas. I am going to introduce the system within the robotics lab of the Carlos III University of Madrid. The main developers of this system are Carlos Balaguer, Juan González Victores, Alberto Jardón, and myself. This is the preliminary design between a human robot and the Azibot. It's a mobile wheelchair-mounted robot in order to assist people with impairments in their day-to-day tasks. As you can see on the top part, these are the hardware systems of our robot. A, the Azibot robot. B, in order to do the interaction of the system, we use the augmented reality goggles with 2 cameras to the front and 2 displays in the internal wall of these goggles that allows us to see the real world, but also relevant information. The system has mounted microphones and headsets and 1 Kinect for detecting objects that we want to manipulate with our robot. This is the system architecture with the hardware, software, the interface controller, and the Azibot controller. I'm not going to go into detail with the technicalities, but this is the architecture suggested for this type of systems. And this is the dialogue of the user and the robot with different voice commands and output voice in order to do specific tasks, as you can see on the slide. It is interesting to see the first image. This is the real kitchen, but you also see tags with the augmented reality information. The entire project is augmented reality based because the devices will become very popular, as it happened with the smartphones in the past. From day one, using augmented reality in the field of design for all and impairments, this adds value to a system that might become very popular. If we all have goggles with augmented reality, it is true that we have we would have been working in the universal design for many years. Well, again, this is the augmented reality interface. This is what the object will look like. And then you can read the dialogue if you want, but the user, step by step, gives different voice commands telling the robot what it has to do, given assistance with the different goggled screens. We have run different studies based on the usability scale. The test came back well, reaching 87 points over 100. Asking the question, do you think these type of systems are useful? And I can't read this properly, but it also explains the main pros for these tests and the questions where we obtained less scoring. And finally, we've tried to do a user profiling, the target being people with a physical impairment that are already affecting the upper limbs, with different spinal cord injuries, and we've come to the conclusion that the system is mainly devoted to people with SCI in the different C645 vertebrae. And I'd like to thank the Ministry and the Acaria project for the support to these projects, and also Robot City 2030, which is co-funding this project. Should you have any questions, please do not hesitate, or please contact us through our website robotifec.es. Thank you very much indeed.
Muchas gracias, Félix. A continuación vamos a seguir.
Thank you very much indeed. We are now going to give the floor to the touch communication for deaf blind people. Juan Ramón García, a technician of the CIDAC, the Research Center, Tiflo Technic Center.
Una de las dificultades más importantes.
One of the biggest difficulties for the visually and hearing impaired is the on-site communication with unknown people, or people that are not so familiar to them, that in general terms are not familiar with the communication. They use the alternative communication, and this is precisely a problem that we've always tried to solve. Nowadays, the most commonly used method to solve this is by means of communication cards. So with a very strong cardboard, plastified in general terms, which can last after the wearing and tearing, which includes one-off messages that the hearing and visually impaired person will need. The messages have to be very direct and brief, because the person won't be able to ask explanations about the message they are receiving. If the if the visually and hearing impaired person is completely blind, there'll be a braille code for the person to understand the message. Now, thanks to the technologies and the iPhone, iOS, and also the Android systems, we have multiple possibilities to come up with a different solution. The solution tries to recreate communication between two individuals, one of them being hearing and visually impaired. And that is the aim of our project. Before we display the app, we would like to explain that the visual and hearing impairments is one disability, that it's a combination of the two sensory disabilities, and it is a mistake to think that this is a combination of both. This is a different disability, different degree of impairment, which requires different solutions to the problems. Now, the app we've developed will be replacing in that communication channel. It'll replace all the other channels, because the channel will now be the device. And the other radical change is the use of the code being used by the visually and hearing impaired person, with different traits on the screen that the app will recognize as characters based on an algorithm and different patterns that we have designed. And they will be done independently of the size or the position of the person doing or writing those drafts. The visually and hearing impaired person will also have the possibility to learn those traits, because there is another part of the app that translates the meaning of these traits, and they can practice to improve them. There is another possibility in the app, that is, if the visually and hearing impaired person has certain degree of vision, they will be able to use the virtual keyboard of these devices in order to create the message, because actually the hearing and visually impaired people might be fully blind or deaf, but in this category we also include people with partial visual impairment or partial hearing impairment, but they are all within the same category, visually and hearing impaired people, and this is the goal and target of our app. Imagine a visually impaired person wants to communicate with a visually and hearing impaired app. Well, we need to include the screen review in the entire process of this communication. All the functionalities of this app, or the most common functionalities, aim at facilitating the hearing and visually impaired person the creation of messages, thus allowing the recording of a list of pre-recorded messages. You can also delete them or create them again, or create new messages, but you can also use the latest written message by the hearing and visually impaired person, or the last one written or recorded by the others spokesperson or stakeholder. In the Android version, you can synthesize the message created by the hearing and visually impaired user for the other person not to need to read the device. The application allows you to copy and paste messages from the hearing and visually impaired person with the aim of using them in other devices or other apps of these devices. And finally, please note that you can adapt and customize the size of the messages, the contrast and brightness can be modified, and also the way in which you will be told we haven't recognized your message, either by blinking or vibrating. This is the solution that we have developed in our R&D center in the ONCE Foundation, with close cooperation with the hearing and visually impaired unit of the ONCE Foundation. Thank you very much indeed, and please do not hesitate to ask any questions afterwards.
Muchas gracias, Juan Ramón.
Thank you very much, Juan Carlos. We will now continue with the labor integration services for impaired people with connected TV. The poster will be presented by Carlos Alberto Martín Edo, accessibility manager of the audiovisual telecom department in the Department of Systems and Telecommunications of the Politécnica University of Madrid. Thank you very much, David, and good morning, ladies and gentlemen. I'd like to explain what smart TV means, or hybrid TV means. This is a new technological paradigm with an Ethernet reader that are capable of receiving content with a traditional network and the internet.
Possibly you've seen a campaign on Televisión Española, the national TV, which has pushed the red button. What they have done is to program applications, including video upon demand, which is available on your screen, broadcasted through the internet if you push that red button. Obviously, this offers great possibilities to get new contents and services through your TV screen, because you will do this through the broadband and through a channel which is always connected to it. So the question that we were posing ourselves is how to make the best out of these possibilities to offer accessibility services and new services for people with disabilities. The answer to this question was provided by the INADIS project for work integration for people with disabilities. Based on the Indra professorship in the Ateco Foundation in University of Madrid, we've created 4 services for work integration for people with disabilities. These are accessible services which can be accessed through the TV screen. We offer these services that, as it's shown on the central part of the poster. We have multimedia training courses that can include text and images and videos. A second tool shows real job positions offered by the Adeco Foundation, which are especially aimed at people with disabilities. They can make searches through profession approaches and through geographical areas. The third tool is access to internet forums. This was requested by the Adeco Foundation because they knew that people with high training in the ICT sector that had a disability did not find a way to find a job towards work integration. And the fourth is a portal that provides static information regarding administrative procedures for people with disabilities. These are services addressed at people with disabilities, so it was required for them to be accessible. In order to do so, we use different strategies. Mainly, we use the characteristics of the standard itself. The HD TV standard, which is a connected TV standard that we've based our works upon. For instance, we included audio clips with descriptions of the different tools in the forum. We also carried out tests with a red speaker to explain the contents in the different tools. Also, there is an improved graphic interface that maximizes contrast and font sizes. There was a need to do data mining on the internet for this multimedia content. So this is something that we used so that we could include video clips with sign language descriptions. We've also followed accessibility standards and content accessibility standards. We took into account browsing capabilities so that the user can know where everything is located within the different tools. So this was a brief summary of our work. If you want to have further information, we will be pleased to provide it to you. We'll be standing by our poster outside, and we'll be more than happy to receive you at the demo center that we have in the School of Telecommunications Engineering. Sorry. We are going to finish up with a project called Methodology for the Study for Learning for Children with Brain Paralysis in their learning process. Javier Galaza is at the Engineering Study Group in CSIC. I'm here to introduce work undertaken by the Bioengineering Group in CSIC and in collaboration with the San Rafael Hospital. This work is framed along a research line that tries to design interfaces for computing access for people with motor disabilities. Specifically, we are working with people with brain paralysis. They have motor alterations which are quite serious. They have problems with their posture. They have involuntary movements. and they also display cognitive alterations. All these different impairments limit their movements, the manipulation of objects, and their communication with their environment. We've realized that computers and video consoles are great tools that can be used even in rehabilitation therapies, but one of the key problems is that not all users are capable of accessing them. Not all users can deal with a video console remote or a traditional keyboard. So, indeed, there are many available devices that try to overcome those deficiencies, such as customized joysticks, alternative keyboards, adapted mouses, to systems such as Kinect that actually locate the position of limbs. Also, they use the iris positioning to manage this type of tools. So our contribution from CSIC is Enlaza. It is an interface addressed to those people who have very serious motor impairments, and they're so serious that they cannot manage any of the previous devices that I mentioned. They have no control over their hands. That is such a serious impairment that they cannot access to those devices. So we presented the Enlaza interface. It translates the head movements into movements in the mouse browser on the screen. So this can be used by the therapist to rehabilitate the user and to translate their movements and their posture. In this study, I'm presenting a methodology to assess how the user should be using the Enlaza interface. There's a learning curve from the first time they use it and throughout the sessions. In order to do this, we have presented a pilot research study. Materials are the Enlaza interface and a simple video game where the user needs to click on a figure that appears on the screen. We have one single user, which is a child, which is dystonic, spastic, and has brain paralysis. She goes to the special education center in the San Rafael hospital. According to the methodology, the child needs to click on a shape or a figure that we can see on the screen. Perhaps you cannot see it on the screen right now, but I can delve deeper into it when you visit us at the poster. So whenever she clicks correctly, a video fragment will be played, and this fragment has been selected by this child. So this type of leisure activities are very beneficial for the child because she feels more motivated. Indeed, we measure the time that it takes for the child to undertake the task. We take into account the difficulties that posed by the task, which is how large is the objective, the item on the screen, and how far it is from the screen. If it's very far away and small, it'll be more difficult to reach. And we measure the average between the two indicators that I mentioned. I'm not going to focus on the results right now because I don't have much time, but we measure an average time which is 3 bytes per second. This is the input, and a healthy user would have a rate which would be 3 times lower. Well, what are the outcomes inside of the results? Indeed, it seems to be a robuster measure than just measuring the time that it takes for the child to undertake the task, because it takes into account the difficulty of the task itself. We realized that we couldn't really measure and improve in performance from the first second until the last, from the first session until the last session. We can see that there is an improvement between the first objective and the last objective. In the first session, we had 10 objects that need to be clicked on. We want to have more users involved in this research study so that we can have more significant results that will enable us to determine if there really is a learning curve. And we want the tool to be used by therapists as an objective measurement of the user's capacities. If you have any questions, I'll be pleased to answer them by our poster in the poster session. So this was the end of the poster session. We are going to have a 5-minute break. We then will resume the conclusions of the Congress. And I would just like to demand a round of applause for our speakers who've done a wonderful job.
It's over.